Ready, sir.
Good morning. Myself, Dr. I. Gerald Christopher Raj, Coordinator for PSNA Bluetronics Center of Excellence. It is my pleasure to welcome you all for this Internet of Things webinar organized by Bluetronics Center of Excellence, PSNA Bluetronics Center of Excellence. It is one of the COE under the control of Department of IIoT, PSNA College of Engineering and Technology. The PSNA CET is a premier institution in Tamil Nadu with the international standards. It was established in 1984 at Dindigul. The PSNA Bluetronics COE was established in 2019. The Department of IIoT is partnering with Bluetronics Bangalore to provide innovative technological knowledge to the student community. The IIoT, it is changing the industrial landscape, enabling original equipment manufacturers to generate new sources of revenue and offer data-driven services. But building the infrastructure for an IIoT transformation is challenging, as it requires expertise in embedded software, IoT devices, cellular connectivity, and cloud services, and etc. So, the goal of this webinar is focus how IIoT can help to improve the performance of your everyday life. In day one, the resource person will discuss the basic concepts behind the IIoT. What are the components used in IIoT? He will discuss. And in day two, he will give the hands-on training. Right? No need to write the codes for programming, just graphical user interface programming, drag and drop kind of application. The day three, a small hardware demos will be shown to you. So in this moment, I would like to thank the management of PSNA CET, especially the co-chairman, for the encouragement and the support to launch this kind of webinar series. I would like to thank the principal of PSNA CET for providing necessary approvals and arrangements. And finally, the motivational force behind this webinar is my head, Dr. V. Rajasekaran. And he is the man behind us. He advised us to change an event to a mega event, because 2 days before we planned to limit the participants to 200, but he advised try to allow the participants as much as possible. So he transformed this event into a mega event. Thank you, sir. Now I would like to hand over the session to Mr. Rajarajan Ilango, founder and CEO of Bluetronics Bangalore. Here, I am very happy to inform you that he is one of the notable alumni of IIIT department. Once again, I welcome you all and Rajarajan for this webinar. Thank you.
So, good morning all, and hi everyone. This is Rajarajan from Bluetronics, and I'm going to handle this webinar on behalf of IIoT Lab, PSNA Bluetronics COE, PSNA College of Engineering and Technology. And before going into this session, I would like to get some small inputs from you all audience. So I hope the screen is completely visible to you, right? So if the screen is visible, just type in the comment like screen is visible for us, so that we can proceed from there. So I request all the participants to comment in the live chat to check whether the screen is visible or not. So the participants who is attending, kindly mention in the live chat that the screen is visible or not. So now kindly go to the browser So kindly go to the browser. Kindly go to the browser and type menti.com. Just go to the browser and type menti, menti.com. I request all the participants to go to the browser and type menti.com, menti.com. So in the website you have a small text area to enter the code. So over there you just type 394834. So it's the common code for all of you. So it's a common code for all of you. So kindly type the code in the menti.com website. It's 394834. So the same code has been entered in the chat as well. So after typing the code, kindly press submit. So after typing in the code, kindly press submit and you choose your qualification over here. This is just to know a small input from you all, like how you are well versed about this webinar, so that I can give you more examples as well as instructions for you to practice in this 3 days. So kindly select the appropriate qualification in the link. The code for the menti.com is 394834. Okay, so I hope you all answer the first survey, so we can move to the next one. I will wait for 2 minutes. You can finish this first question. The code for the menti.com is 394834. It is a common code to all. Everyone can just enter this code. No need to sign up for anything. Just go to menti.com in a browser and type 394834. Okay. Okay, so we will move to the next question right now. So in this, there is an option popping over in your website called go to slide. So just click that go to slide now. So in your web page, now you will be having a pop-up with the button go to slide. So you click that go to slide now and answer the next question. So in your web page, there will be a pop-up. called go to slide button. You just click that and answer the next question. This survey is done just to get a input from you all participants, so that during this webinar in the following 3 days we can give more inputs. So that is the reason we are collecting this small information from you all. Okay, shall we move to the next question, the last question? So this is a normal survey, so if someone who have misread, it's not a issue, you can ignore it. So those who are surveying the questions alone can participate. So those who have enrolled now and come to the YouTube live session, if you have missed this survey, this is just a normal survey, you can ignore it, and those who are answering the survey alone can participate. So we can move to the last question. So from these questions, the results have came as like many of the people doesn't have much knowledge about the Internet of Things, and you are going to start from this webinar. And many of them said they have known the technology only related to the academics. So we will follow from this. Okay, so thank you all for these questions, and we can go into the presentation. So is the presentation screen is clear for everyone? So I hope the presentation screen is clear for everyone. And all the day's presentation will be shared to you all to your respective mail ID at the end of the day. So all these presentations and the PDF and necessary files what we are going to have in this 3-day session will be forwarded to your email ID, registered email ID. So already Gerald sir have give a broad introduction about the IIoT lab which is set up at PSNA College of Engineering and Technology. So this is a small introduction about our IIoT lab, and it is commissioned just to have a broad exposure on Internet of Things and industrial Internet of Things, and we give some sort of consultancy works and trainings to students and research scholars and industrial people. And the motive of the platform is to make the what to say, so it's just to clear the bridge gap between the industrial guys and the academic guys. So as I said earlier, this session also will be of a practical exposure session. So we will have more simulations, we will be having more tools to work with, and if you have any more information to be clarified, or if you have any more information need to be known, you are requested to email us so that we can give you much more clear information on the required queries. So with this we can start the session. So as we have 3 days, these are the agenda that is going to be happening over here. So in day 1 we will be knowing and discussing about the embedded systems and the control methods, and how the Internet of Things evolved, and the comparison of the Internet of Things protocols, and what all the confusions we have in this. Like we may read some information from the blog, or we may read some information from some tutorials or some projects. So there may be some myths and facts about the embedded systems and Internet of Things we are going to consider all those things. And in day 2 we are going to work exclusively with the simulation tools and the web tools, and in day 3 we are going to have a live hardware demo of some of the use cases and also some suggestions. So as a beginner in IoT, what are all the hardware platforms available, what are all the software tools available to work with, so what are all the recognized methods and academic license we can procure from the sites to start initiating the work with the Internet of Things. All those things will be covered in the day 3. So let me start our day 1. So in this session, if you have any doubts alone, kindly mention in the chat, or else if I ask any question, do mention in the chat. And other than that, you can just patiently view the live screen which is projecting to your laptop or mobile. Okay. So let me discuss about the myths and facts of the embedded system. So for the audience who is not getting the live screen, I would like to request them to refresh their browser and to wait for the live stream to get synchronized. So for the audience who are not getting the live stream, kindly refresh your browser. So while we are discussing about the myths and facts of the embedded system, many people, even the faculties or industrial people, think that if there is a chip with a clock, then that can be categorized under an embedded system. So a chip with a clock is normally categorized as a digital electronics, and it will not come under embedded system first. And only the device with CPU and programming capabilities can be categorized under embedded system. So what is meant by embedded system? So if there is any application which is need to be done, for example, controlling a temperature or getting a motor speed done at a particular RPM, or a closed loop control, or need to retrieve a sensor value, such kind of application, if you are writing as a code or a software or a piece of information, which are going to embed that into any form of system on chip, or chips such as a microcontroller or PSOC or microprocessor, is collectively termed as a embedded system. So that is what we call as embedded system. And in the picture you can very well see the small elements of the embedded system, which has a software and hardware given over there as a termed as a embedded computer with the user interfaces, IOs, and link for other systems which is meant for communication. So we will be dealing in detail with the communication little later. And while discussing about the next myth and fact, like for example, if you are writing a blinking program or a blinking LED program for a controller, and many of them thinks that if they generate a hex file or a bin file, then just by changing the pin number of the program, that will be or that can be ported to any other microcontroller or any other microprocessor module. It is not like that. So the hex file or bin file, what is being generated at the output of your embedded C code or your Arduino code, is solely depends upon your board architecture or your processor architecture and your clock speed. And that is why you will be having some error if you port the same bin file or hex file generated for one microcontroller, and that is being ported for the other microcontroller. So a bin file or hex file is nothing but a hexadecimal values which has been stored in a multi-dimension array in the address of the chip. And to the side of the slide you can see a small utility program which shows the bin file. So here the bin file is being opened up here, and the same bin file is stored in the address of the chip. So here as an example they have given a STM32 chip. So this is how a bin file or a hex file will look like, and it changes from a controller or a processor architecture. Okay, so the fact is the generated file will not hold for all microcontroller, and it depends upon the architecture and the clock speed. And the last myth is, if I enable a serial communication in one microcontroller or a microprocessor, then it can communicate with all the other computer or other microcontrollers which also have the serial port. But it is not like that. So actually the thing is, though the serial port is set, you have to set the right baud rate, and baud rate is nothing but number of bits measured per second. And the baud rate is also called as the symbol rate or modulation rate. And this modulation rate and symbol rate are the very old names. And to the right side of your slide, you have a table over there. So have you ever think why the baud rate has been set to a particular defined rates? For example, 9600 or 115200 or 38400, like that. So it is done so by the registers which is present or which is necessary for the baud rate generation, and those were called as UCBR in the UART or the USART of any microcontroller architecture or microprocessor architecture. And there is a clock specially given for that which is called as baud rate generator clock. And this UCBR and this baud rate clock both are necessary for defining the baud rate in any processor's microcontroller architecture or a PSOC architecture. So based on these two, these baud rates has been defined, and there is a baud rate formula also is there to calculate the baud rate from the UCBR value and the baud rate clock value. So if anyone wants more information on that, I can specifically mail to those participants regarding this thing. And the person or the company who formulated this baud rate formula initially is the IBM, and then it was acquired and redefined by the Intel, and from them we are following their standards. So moving to the next fact. So many of them have came across this word open source, but let me have some discussion on what is mean by the open source actually. So open source is nothing but it's a division where the publisher can give their source files and software codes and other related design files, and the person who acquire those files can modify or redistribute, or they can put up their own branding without the permission of the publisher. So it is free to use, it is free to modify, and it is free to change. And open source is completely different from freeware. So what is meant by a freeware? Freeware is just a small piece of software or code or hardware which is just free to use. So the user is just allowed to use the software, and he doesn't possess any rights to either modify or to redistribute. So that is the main difference from the open source and the freeware. And when talking about the open source hardware, there are four major organizations in the world: Open Source Hardware Association, and Open Source Hardware User Group (OSHUG), and Open Source Hardware, which is comes under the Open Source Initiative. So if any person is manufacturing an open source hardware board, for example, as you see in this picture, you can find an Arduino board and you can find a Raspberry Pi board. And these boards, before declaring it as an open source, they need to get certified from any of these associations, and it is of course free of charge. So if your college or if you are individually coming up with any open source board concept, you can get your board certified with any of these associations. So you can even I hope seen the logo at the back of the Arduino board. It's termed as open source with the infinity symbol, which is the official logo of the Arduino. And the bottom part, we have a small development kit which is based on the ESP32 platform, by express if, and the center black color board is the Beagle bone from Texas Instruments. So we will be going to have the demo on this ESP32 based board on day 3. I will let you know what is the feature of this ESP32 and how to use this, and what are all the other parameters in the board, and what is the strict alternatives for this ESP32 board. Everything tomorrow in day 2. Okay, so in day 2 we will be exclusively dealing with the IoT platforms for both hardware and software. So when we speak about the applications of the embedded systems, so embedded systems is there in every major product what we are using in our day-to-day life, ranging from a small debit card machine or a ticketing machine in bus, or the traffic light which gives out the proper timing signals, or our Wi-Fi modem through which we are all communicating now, or in petrol bunk after putting the petrol we can have the counter which gives out the pricing details and the amount of petrol we have put over there, and in ATM machine which is a GPS connected IoT product where we can have the transactions with our currency either digital or through cash. And even in our household we have microwave oven or tape recorder or mobile phone or washing machine. So embedded systems is there in all. So here a small tip, we all have a set-top box in our home, and even in our LED TV we have all the menus popping up while we are changing the volume, or in the settings menu, right? So that is nothing but embedded Java which has been written as a open source and has been distributed over there, and people also have some proprietary embedded Java code written for exclusively for this infotainment devices like in our car dashboard and TVs. So as example we take up a washing machine here, and the components of the washing machine, like the outputs we have small displays for timing information, and the motor speed which turns out the washing machine rotor, and we have a small CPU, RAM and memory for storage of all the settings for a fully automatic washing machine, and we have some button inputs also, right? So with this we can go to the control methods. So I hope you have a small idea about the embedded systems, and I don't want to dive deep into that. Okay, so in this slide you have the control methods done over here. So control methods means by which the appliance is going to get controlled. So in this video you have a small wiring circuit of AC split AC being given over here, and it has been controlled with the remote, right? So what is the advantage of this particular control method? So by this method we can able to wirelessly control from anywhere in our room or within the range of the AC. But the disadvantage over here is the control can be done only till the range of the remote appliance or the remote control appliance. So here the range is limited, and also the control can be done outside the range. So we have to note one point here: whatever the device which is going to be controlled or which is going to be monitored by any sensor or by any actuator, then that device is called as a node or thing. Okay, so I'm repeating it again. So whenever a device which is going to be controlled or monitored by any sensor or actuator, then the particular device which is going to be controlled or monitored is called as a thing, okay, or a node. So that's what I have given over here. And moving to the next slide. So in this slide we have one improved control system where we have replaced the remote with the home automation panel. So with this home automation panel, we can have one panel in our house installed over there, and this panel can communicate with the node or thing over any wireless medium like Zigbee or Bluetooth or Wi-Fi. So with this, what is the advantages? With the one panel, I can control all the curtains in my house, or I can control all the AC in my house, or I can control even all the heater or any other pump which is present at the water tank control. So all those things I can do with a single home automation panel. And here what is the limitations is, though I can able to log the parameters like the energy consumed by the equipment, or any other parameters like the timestamp, like at what time the load is switched on or what time the load is switched off, all those things. Still, I have a limitation to control that within my home. So this is one limitation what we have in this kind of control methods. But the advantages, we can control this anywhere in the home. So now assume there is a application where I have more air conditioner systems installed in a cinema theater, or in a shopping mall, or in a very big multi-complex, or in any kind of IT offices, or as a whole apartment where I am installing more than 40 to 50 devices. So at that moment of time, I have to stream all those access of these devices via a unified device called a gateway or a router, and from this router or a unified device only I can able to access via a unified client that can be your mobile phone. Okay, so the communication between your gateway and router can now be either through Wi-Fi or Zigbee or Bluetooth or a wired Ethernet, or even LoRa, or any kind of wireless connectivity protocols. And the other side, from gateway to router, it can be of through either Wi-Fi or Ethernet. And here the main advantage is, with a single panel I can communicate to any of the device by setting the address of the device. For example, if there are 50 devices present over here, I will set address for this as 1A, 2A, 3A, 3B, like that, and I can call that address, and then I can send the command to control the AC, or I can receive the parameters from the AC, like what is the temperature, or what is the humidity, or how much is the current consumed from the system one time. Like that, I can able to get all the parameters from this AC and streamed through the gateway with this common client. So this setup, which has a node or a thing and a gateway and a local client, and we call this as a intranet control system. So intra means within, net means a network. So it is an intranet control system kind of control. Okay. And coming to the next slide. So here I have classified all the available IoT connectivity protocols with respect to distance and applications. So if the distance is short, and if you want to have multiple streaming of application, for example, I want to send data every single moment, then I need to go for a Bluetooth. And if the data type is varying, for example, I need to, if I have installed a security camera, and if there is any new person coming to my house, then the camera has to capture that particular person's face using a face detection, and then it has to stream that person's image over the server. Then I have to go for a protocol with higher bandwidth like Wi-Fi or Wi-Fi direct. Then if I have to control more 10 to 20 devices at the same time, which is we called as a mesh network. So at this moment we have to go for a Zigbee, and all these things which is present in the third layer is called the proprietary solutions developed by some company, and these are not open source. Only the things which is present over in the first two layers were open source, and we can use them without any license, and the applications for the same is given at the end of each data. Okay. And this is the comparison chart for all such protocols, and what is the implementation cost, and what is the power consumption, and what is the power being taken while it is in operation, and what is the band of frequency. So everything is being given over here. And of these, if you want to have a very low power, and if you want to control more devices using a single gateway, then LoRa is the best. And if you want to have a peer-to-peer communication or one-to-one communication, then Bluetooth is the best. And if you want to have very time critical data and mission critical data to be sent over the server, for example, you want to send a boilers data which is very much critical. If the data has been having some lag in communication, then your boiler may get burst out or explode. So at that time you have to go for mission critical protocols like Wi-Fi. So likewise, based upon the usage, we have to choose the protocols. And coming to the last slide in this, so here we have a multi-thing setup. Multi-thing setup means like the 40 to 50 nodes we have installed in the mall or a shopping mall. Now such different sets of devices, it's now grouped together as a multi-thing setup, and this multi-thing setup is now being communicated via the gateway. So since there are more than many devices being present over here, and all may have such IDs, and their data wants to be retrained locally. That means I want to store the data of all these 100 devices, 50 devices locally, then I am going for a local server. So local server manages all these devices or nodes or things, what we call over here, and from this server I can able to access the nodes or the device management of these nodes via any local client 1 or local client 2. Okay, so this is the complete setup, what we called as intranet of things. So what is the intranet of things? So intra means within, net means network. So within the network I am going to connect and manage all the things which has been present over here and with the local client. So this complete setup is called as intranet of things, and this intranet of things is being termed as connected things also by some of the people. So they may call us either intranet of things or as connected things. So at this moment till now we are not using any internet, or we are not using any remote server or remote client. We are just speaking about or discussing about only the local client, local server, and the setup. So this is a typical architecture of a factory where we have all the base depicted with different colors. Red is depicted for the system is shut down or it is in repair, and yellow is it is waiting for the next shift to operate, and all the green base are in production, and some parameters given over here. So here the depicted picture over here is all the nodes are connected to gateway via different protocols like Wi-Fi or Bluetooth or Zigbee or Z-Wave, or even with the internet through our gateway, and from the gateway it is connected to the local server, and using a local client anywhere in the factory I can able to monitor the status of the factory. Okay, so this is the complete connected things or intranet of things architecture. Okay, so what is the limitation of this structure? Though I have many advantages like storing the data locally or getting the all such parameters to a common local client and controlling all those devices through the local client, everything is possible over here. But one thing what I felt disadvantage over here is I cannot access this complete setup outside this local network. So for that case, I am connecting this complete network to internet. So when this complete network is connected to internet, then this intranet of things or this connected things now becomes internet of things, and that what we call as IoT. Okay, so when all these devices is been communicating via gateway and it is been sent to a server, and that server is now connected to internet, and in internet we are having another one server where we are storing and analyzing the data, and we are doing all such device management in the internet server, and we are accessing that with the remote client. For example, if a factory is there in Chennai, I can able to access the factory's parameter in Coimbatore, or I can able to access the factory's parameter in Bangalore, or I can able to access the factory's parameter even in Antarctica also, if there is internet access. So globally I can able to access the factory's parameter once it is connected to internet, and now I can have a real-time monitoring over there, and from there I can able to store, manage and control all the things in the device cloud server. Okay, so this is the IoT. And IoT, the main advantage is it gives global access, and whereas the intranet gives the access only on premise or within the factory. So this is what we called as IoT. And some of the persons, you may have used a Raspberry Pi, or you may have earlier used any other computer, and from that computer you may have some dashboard, and if you are going to control some Arduino boards, unless otherwise it is not controlled via internet, then it is called only as a connected things or intranet of things only. But if you are connecting such Raspberry Pi boards or any other this ESP32 boards to some IoT clouds like ThingSpeak or Ubidots or Blink or Kane or Locent or Atmosphere or Microsoft Azure or AWS or Google Cloud Platform, then only if you are managing and monitoring to those, at that moment only we can call them it as IoT. Just to have a Raspberry Pi and creating a dashboard in the Raspberry Pi and communicating via MQTT or through REST and controlling the motors or any other relay boards doesn't account for IoT. So this is the simplified architecture of the IoT, where we have the similar setup. So either we may have the devices, and this devices is communicating through the gateway, and it is now communicated to the IoT platform where we can have the further analytics. And there is one possibility where if we have a 4G enabled gateway, if we have a 4G enabled gateway, then there is possibility without the connecting of the gateway we can able to connect it to the cloud. For example, let us check a agriculture land where we have a soil moisture sensor, and it is connected to an Arduino board, and that Arduino board is having a 2G SIM modem or 3G SIM modem, and that is directly speaking to your IoT platform. Now your Arduino board plus that GSM or 3G 4G modem together act as node plus gateway here. Okay, so there is no separate gateway needed. So here together it is called as a node plus gateway, and that setup sends your temperature or soil moisture values from your agriculture land to the IoT cloud. Okay, so the next thing is we are going to see about the IoT verticals. So IoT verticals is, there are some important terms what we need to know before going into the technical aspects of the IoT. So in this picture you can have a broad inverted triangle over here, and aside to that you can find a triangle structure and the flow. So these two diagrams are the flow of the IoT mentioned in a simpler terms, and these two things are, or this inverted triangle is the complex architecture of the IoT vertical. So in your TCP model or OSI model, you can have many layers like session layer, link layer, or management layer, application layer, like that. So for each layer, what are all the protocols responsible and what are all the softwares responsible is being given over there in the inverted triangle. For example, if the device is being connected using this PLC or RS485 or Modbus or Wi-Fi or Zigbee or Bluetooth, using any protocols like MQTT or HTTP, then using any method of server like RapidMQ or Flu or Kuka, or it's been now sent to storage for any database like Hadoop or Cassandra or MongoDB, and then only it's sent to cloud, and from this cloud we can able to access either for our business reports or for data analytics or for device management, that is to switch on or switch off or to set the proper speed in the machine, like that. But if you see here, for all the layers been given over here, you need security and privacy, without which if this has been hacked, then you will lose all the data or control. So we have to give a proper security and privacy layer for all the layers which is present in the inverted triangle, and IoT security is a very big subject, and that we can have it as a separate session if you are really interested. And as a simpler structure, we can say here there are things which is connected to gateway and that is connected to cloud, and between this cloud and gateway, if you want to analyze the data, for example, I am getting a raw value from a temperature sensor, I want to convert that to Fahrenheit, and then I have to push to cloud, then I have to do a separate processing called edge computing. So if I don't need that, then I can do all the things in the cloud itself. Okay, so this is the small structure of the IoT. So I hope you all have some clear idea about IoT now, right? So if you are not understanding anything, or if you want any explanation, you put up in comment. So if you are still having any doubt about this flow, like from sensor to actuator, the data are retrieved and collected by any IoT node or thing, and from there it is sent to a gateway, and from there it is connected to a internet cloud, from where through a remote client like our mobile phone we are able to access the sensor parameters. So this is how the IoT works, and if it is clear for you at this moment and you are clear with the IoT concept, I can proceed. If not, if you have any doubts, you just put up in comment, I will explain that again. And about the LoRa and LoRaWAN technology, in day 2, while we are explaining about the sessions for IoT hardware platform, I will explain you completely. And edge computing also, edge computing I will separately explain as a separate topic in day 2. So all those things are coming under IoT hardware platform, and I hope I can proceed to the next. So the PPT will be sent to your email IDs respectively at the end of the 3rd day. So all the day 1, day 2, day 3 PPT along with the tutorial for using the web tools, everything will be sent to your individual mail IDs at the end of day 3. So you can have the PPTs for reference, and we will surely send that. So here, before proceeding into the different communication protocols, I would like to clarify one thing. Whenever we speak about IoT protocols, the people will get very much confused whether to categorize which protocol under which category. I will explain what is what are those. For example, all these Bluetooth, Zigbee, LoRa, Sigfox, NB-IoT, or Wi-Fi, or Ethernet, or even our RS-485, Modbus, LoRaWAN, Modbus TCP, or Profinet, or EtherCAT, all those things are connectivity protocols. So we can term these as IoT connectivity protocols, which is responsible for connecting your nodes and gateways. Okay, so or from your even from your gateway to your local server. So all these are termed as IoT connectivity protocols. But from your local server or from your node, you are going to pass this data to the cloud, right? So that is what we call as communication. So for the communication, we have separate protocols in IoT. That's what we call as data distribution service, or DDS, or advanced message queuing platform, or AMQP, or constrained application platform, COAP, or MQTT, message queuing telemetry transport, or HTTP, I think you know, and it's XMPP. XMPP is the protocol which is used by Google in the Google Glass product, but they have stopped that right now, that product, but yet the XMPP is still available. So while we are speaking about this IoT, or when some students or in any conference or in any paper, while you are reading about this IoT, please make it clear, and please be strong in your point that all such Zigbee, LoRa, Bluetooth, Wi-Fi, Ethernet, Sigfox, all are IoT connectivity protocols, and all these COAP, MQTT, REST, or XMPP, or DDS, all these are communication protocols. So those connectivity protocols like Bluetooth or Wi-Fi helps the device to pass the information to cloud via these communication protocols. So we have to be very clear in this. So don't confuse with this communication protocols with the connectivity protocols. Okay. So of all these protocols, COAP, AMQP, and MQTT, all these three are mostly used in all the devices which we are using in our day-to-day life or even in industries. So we will be concentrating more on these three protocols, and primarily with the MQTT protocol. Okay, and if you want information about any other protocol which is not right mentioned over here, you can very well contact in mail, or if you want a separate tutorial for any DDS or XMPP you want to have, then we can have as a sequel of our next webinar if you are interested, and we can dive more deep into that. And speaking to the IoT layer, we have the TCP model given over here. So in this TCP model, we have a normal TCP model for the web stack, and this is the TCP model for your IoT stack. Okay, so we can compare and contrast the IoT stack and the web stack models. And here I have tabulated the different layers and the associated protocols from that inverted triangle diagram what we have seen little earlier in the previous slide for your easy information. And here, as far as the usage of the communication protocol and connectivity protocol, it solely depends upon the application. What kind of application we are going to use, and for that application only we have to choose the right IoT connectivity protocol and the right IoT communication protocol. So after the demo, tomorrow in day 2, in day 3, we will be exclusively dealing with how to choose the IoT communication protocol and the IoT connectivity protocol for a particular use case. We will be defining many use cases like a use case for agriculture, use case for industry, use case for home automation, and a use case for healthcare, and use case for truck management. Like that, we will be defining many use cases, and we will be discussing about the IoT connectivity protocol and communication protocol, which is good and which is best. Okay. So of all these protocols, IoT protocols, the Google has given the trend chart in 2019 March, and of those, it itself says that MQTT is widely used in all such informations. Okay, so even if you take many applications like toll gate, or even in some applications where we'll be having some RFID tag being worn in our hand, and we will be asked us to enter inside any conference or any five-star hotel. So all these things are communicating via MQTT only. And even our RFID tag in our car, which is been that information retrieved by the high power RFID scanner which is installed at the top of the toll gate shed, communicates to the server via MQTT only. So as MQTT is in much trend, we are going to see what is MQTT and what is the usage of the MQTT, and what are all the things we need to consider while using this MQTT. Okay, so I have just put up some small sparks on all these features. So while speaking about the MQTT is the far best lightweight protocol of all the protocols we have used. For example, it can handle any type of data. It can be a number, it can be a binary format, it can be a hex file, or it can be any packet, or it can be a group of data like array, or it can be a JSON data, or it can be any kind of XML format, or it can be any configuration settings file. So it can be of anything, and all such different data types is being supported by MQTT. That is the very first advantage of this protocol. And the MQTT is being invented by the IBM company, and till 20 years back, like 1996 or 1997, it was used internally to pass the messages between the IBM servers. So I hope the CSE guys who are attending this webinar knows much about the IBM servers and also the old IBM servers. So after the 1996 or 1997, IBM have open sourced this protocol, and that has been undertaken by a company called Oasis Foundation and Eclipse. Eclipse is the IDE what most of the people were using to program your Java applications and Android development and all. So those Eclipse Foundation and Oasis Foundation together got that in charge, and it has made that MQTT standard, and MQTT 3.1.1 is the latest version what we are using right now. Okay, so MQTT has many versions, and there are three different modes of MQTT, like the quality of service, what we call it as. So the quality of service means is QoS 0, QoS 1 and QoS 2. So what is QoS 0 means? It's termed as utmost ones. It's nothing but if a person is sending a data through MQTT to the other person, till the other person sends the acknowledgement, it will send the data continuously till the receiver acknowledges that I have received the data. And QoS 1 means at least once. That means it will just check for acknowledgement, but not that much as the QoS 0. And QoS 2 means exactly once. Here the publisher or the person will not check whether the acknowledgement came or not. So he just sends the data and he leaves as such. So this is what the 3 levels, and we will be using QoS0 for our application demos as we are a beginner. And when we speaks about the architecture of the MQTT, so in MQTT it is basically a publish subscribe architecture. Okay, so MQTT is basically a publish subscribe architecture. That means you have a server, and we call that server or a IoT server as a broker in MQTT. Okay, so the server is called as a broker in MQTT, and we will be defining many topics inside the IoT server or IoT broker. So topics is nothing but it is a medium of information through which the publisher and the subscriber are connected. I hope you got the point. I will repeat again. So there is a IoT server which is called as IoT broker, and inside this IoT broker there are many topics defined, and this topics is been defined by the user only. The person who is going to program, he will define this topic and he will give the name, and this topic is nothing but a medium of information which connects the publisher and the subscriber. Okay, so this publisher will publishes his message under the topic. For example, let us assume the publisher is publishing the messages under the topic blue. Okay, under this broker. So if this subscriber is having access to the same broker, and if he is subscribing to the same topic blue, then whatever the message been published by this broker is being accessed by the subscriber. Okay, so by this method one publisher can publish to any number of subscribers. There is no limit for the subscriber to add to a network. That means I can give a single command to switch off 10,000 machines at once, or using a single topic I can collect the current sensor data or voltage sensor data or temperature sensor data from 10,000 machines and I can store it. So this is a many to one or one to many kind of architecture, where using a single publishing message or topic we can able to retrieve a lot many data from different machines, and this is the main advantage of MQTT over all the other protocols for which it is been widely used in IoT. Okay, so if I need to give a topic under a topic, let me come to the next diagram which is over here. So I have a building as a main topic, and that building has 2 floors as a subtopic, and another subtopic room 1, room 2, room 3, and humidity and temperature and all these things are there. So let us we assume our department building or our office building where we have more floors. Let us assume we have 4 floors in our department building or in our office building, and I want to control that light in the 3rd room of 2nd floor of my office. Okay, so I want to control the 2nd tube light of my 3rd floor in my office. Okay, so for that I have to first specify the main topic, followed by that particular room number, followed by that particular the office, followed by the particular floor, and followed by particular room, and then particular device. So by this, if I give on and off command, then it will comes to only to this device and it will not reach to all these other devices. By this, specifically I can give command or I can publish or subscribe only to a particular device or to the whole of that group of devices. So by this, MQTT is used to get the information or put the information to a single device or to a group of devices. Okay, so this is what we call it as MQTT. and can it permitted to take another 15 minutes of your time, 15 to 20 minutes of your time. If you are okay, you can comment it over here, or if you want to continue this from the day to tomorrow, you can mention that is in comment. So if you can give us some 15 to 20 minutes time to complete this, we can proceed, or if you want to stop the session, I can stop it right now. Okay, so thanks for your comments. I am getting many okays, so I will continue and finish this off. So thanks for your time. So in the next slide, so I am getting many continues. Okay, thank you all. So in the next slide, we are going to speak individually about the brokers. So in the brokers, there are two different types of brokers available. One is a private MQTT broker and a public MQTT broker. So what is the difference between a private MQTT broker and a public MQTT broker means? Public MQTT brokers are mostly free to use, but there is a disadvantage that your data is being exposed to the public. That means anyone can access your data. So if you don't want your data to be accessed by any public or only to a particular group of persons, you want to access the data means you have to opt for private MQTT broker, but you have to pay for it. So there are some limitations for your plan, and you can make some subscriptions for this private or paid MQTT brokers. And this is basically used by the factories or industries or mills where they don't want their data to be exposed by its competitor or any other guy who is manufacturing the same product. So for business point of view, most of the people will go for the paid or private MQTT broker if they were from industries and factories. But for academic use and for a hobbyist or for the students, for the projects, they can go with the public MQTT brokers. And MQTT usually is a TCP based architecture. So either it works under any TCP port or under any WebSocket port. Okay, so I don't suggest this TLS port as of now, and it is a bit again different concept. If we speak about this, it will take much time. So to make it simple, I just say TCP port or WebSocket port is good to use. So a port is nothing but a channel through which application can speaks to the server or to your device. For example, you have a Chrome application, you want to access google.com, then it is speaking to the Google HTTP server via port number 8080, right? So it's something like that. For MQTT also, it has to speak under some particular channel. That channel number is 1883 and it is constant and same for all the available brokers. So like google.com or like facebook.com, this MQTT .flisp.io or broker.hivemq.com or test.mosquito.org or mqtt.eclipse.org, all these websites are the available free MQTT brokers, and we are going to use any of these one. Okay, so of all these we are going to use test.mosquito.org or broker.hivemq.com. So any of the two things we are going to use. Okay, so these two things we will be using for our demo and sessions. So are you ready for the demo? So can we have a demo session right now? So I hope you all have your iOS devices or Android phone in your hand. So can we start the demo? Okay, So the participants who find it difficult to find the application, so this is the MQTT client which is available in the Android Play Store. You can search and install it. Okay. So the person who have Android phones in your hand, you just search for MQTT client in your Play Store and install this application. Or if you have already installed, kindly mention in comment so that I can proceed to the next step. And for the people who are having iPad or iOS or iPhone based devices, you can install MQT tool. Okay. So I hope both the peoples who are having iOS and Android have installed both the apps, right? Okay, so now we can proceed to the demo. So I am projecting my phone screen over here so that it will be easy for you to access and follow me. Okay, so for that I have projected my phone screen. So kindly wait for a moment. I will just project my home screen and I will come back. So all of you have opened this app, right? So I hope you all have opened this app. So the iOS people also open your app and follow the procedure as I say over here. Okay. So for Android app, you just find MQTT client. For Android app, you just find MQTT client in your Play Store. And for your iOS devices, you just find MQTT tool. Okay. And for the iOS people, you can refer to the screenshots. For the iOS people, you can refer to the screenshots, and it is same as what I am going to explain you now. And for the Android people, you just follow my procedure. Okay. So the iOS people, you can follow the screenshots which is present in the App Store, and for the Android people, you can follow my procedure. Okay. So now kindly press the plus button in the right hand bottom of your app. So kindly press the plus button in your right side bottom of your app. Okay, so the first thing is to switch the enabled button. The first step is to switch the enabled button. Okay, so the first thing is to switch the enabled button. And now go to nickname and type any name over there. Go to nickname and type any username over there and give OK. Go to nickname and type any user defined name over there. I have given blue. And now click the host. And now click the host. And for the attendees, for those whose screen is not visible, I request you to kindly refresh your browser page so that you can resume with the updated screen. Okay, and in the host, now type any one of the free broker. Use only small letters. Use any one of the free brokers website name, broker.hivemq.com. For the iOS people, you can refer to the screenshot in the App Store. For the iOS people, you can refer to the screenshots in the App Store. There also you have something called instead of the QR code, you can select the MQTT client in your Play Store in Android, and for iOS users you can search for MQTT tool. Okay, so I hope you have written broker.hivemq.com and given OK in host column, right? One second, I will repeat from the beginning. Once again, I will repeat from the beginning. For the iOS user, you just go to host. For the iOS users, you just go to host and type broker.hivemq.com. And the person who have Android, you just open the app and click the plus button at the bottom of the screen. You will get this window, and you just switch the enabled button as a first step and give any nickname and in the host type any one of the MQTT broker website name. Here I have given broker.hivemq.com. So the host name broker.hivemq.com. Okay. So after giving broker.hivemq.com in host, go to client ID, and iOS people also go to your client ID. Both Android and iOS people go to your client ID and give some user defined name. I have given test TEST over here and give OK. For the host, both Android and iOS people, we have commented out in the chat column. It's broker, BROKER .HIVEMQ.com, broker.hivemq.com. And both the Android and iOS participants, you just go to your client ID and give any user defined name for your client ID. I have given test, TEST. For the host name, refer to the chat column. It's broker.hivemq.com. Okay, so the host is broker.hivemq.com and client ID is test. And after that, press the floppy disk symbol at the top, save. So after that, press the floppy disk symbol at the top. Okay. So I will repeat from the beginning. So here you have the plus symbol. So click the plus symbol. So click the plus symbol, and once you click this plus symbol, first you have to enable this button. So first you have to enable this button, and you have to go to the nickname, and you have to go to the nickname and give any nickname and give OK. I have given blue over here. So I have given blue over here. And go to host, and in the host type broker.hivemq.com. Okay, so in host broker, all should be in lowercase. All the letters should be in lowercase. broker.hivemq.com. broker.hivemq.com. Host and client should be in different name. So you should not give the same name for host and client. So let the client ID be different and your host ID be different. So client ID usually denotes to the device name. That means whether you are having a current sensor or voltage sensor or temperature sensor, that is confined to your client name. And the host name is nothing but the broker, MQTT broker website name, what we are going to give over here, through which the publish and subscribing is going to happen. Okay. So the host ID is broker.hivemq.com. Right. So after giving OK over there, you have to go to the client ID column. And in client ID, you just type something, some test. So all the iOS users and Android users can type this. I am writing test over here and give OK. type test and give OK. The host ID is broker dot hivemq.com, broker.hivemq.com. So after giving the four things, one is nickname, and other is the host, and other is your client ID, and you are giving the enabled button. You just click the floppy button which is present at the top, save button. Okay, the floppy button is the save button. You just click that. Okay. Right. So now you click any one of your ID. You just click any one of your entry which is being given over there. So in the top, are you all getting this connected to broker.hivemq.com, or like the one what I am receiving here, connecting and reconnecting? Kindly mention it in the comment or chat system. So in the top of your application, are you all getting connected to broker.hivemq.com, or are you all getting connecting and reconnecting continuously? Invalid host. Okay. Okay, no issues. To come back, we can change the host. No issues, we can come back, we can change the host. No issues, we can come back and change the host. You just long press the entry. You just long press the entry in the app. You just long press the entry in the app. We can change the host now. We can change it to Mosquito. So long press the entry in the app and change the host alone. It is test.mosquito.org. For iOS user, if you have given the host and if you have given the client ID, only the two things are required, it will get connected. Only for the Android users, you have to follow this procedure. For iOS users, you have to just give the client ID and the host, and you can give connect, it will get connected. So since the broker.hivemq.com host is not active as of now, we can connect to other host called test.mosquito.org. So we are going to change the host alone since it is not working. Since it is connecting and reconnecting, we are going to change the host alone. So to avoid the issue of getting the continuously connecting and reconnecting, we are going to change the name of host as test.mosquito.org, and again I am saving it. So for this procedure, to how to use the app, I will send the tutorial link to your email by the end of today. Okay, so I will just prepare the tutorial for this particular app usage with the screenshot of the app, and I will send to your mail by the end of today, and you can redo once and check. Okay, so I hope there are some connectivity issues for testermosquito.org, so we can try any other thing. We can try other host. Okay, so participants, we can try the other host also. So we can come to host. We can come to host and change the name of host as iot.eclipse.org. iot.eclipse.org. Kindly find the host name in the chat column. We can try the third one, iot.eclipse.org. So change the host name to iot.eclipse.org. Okay, and give OK and save. So if you are getting connected with any of the broker, you just mention that in the comment, or if you are having some issues with that, you just mention in the comment, because I am also facing the connecting issues. So I hope we can stop till this and we can continue from tomorrow. So participants, as we have some connecting issues right now with the application, I will send you the PPT along with the screenshot so that we can try out individually, and for tomorrow we can continue from this step. So we can stop at this moment. As we have connectivity issues, we can resume the app session from tomorrow, and we can have the complete demo on tomorrow. So meanwhile, I will send you the screenshots for both iOS and Android, and I will make it as a document and send to all of your mail. You try out and keep it ready till this step, and from this step we can continue tomorrow. Okay, so I am giving the feedback form link as a attendance also, so kindly paste that link in your browser and make the entry of your feedback, so it will be marked as attendance for your online certificate. So the participants, kindly click on the feedback form link and fill the form so that it will be marked as the attendance for your day 1 for your online certificate. So the feedback form link has been shared in the chat column, so kindly check for it, and I will post the day 1 tutorial and PPT to all of your mail. So for your attendance, and we need your feedback for this day 1, so kindly check on the link given in the chat column 1. Link has been given in the chat column. Kindly check under the name Bluetronics. Kindly check under the name Bluetronics. We have given the chat link and fill that. So since the participants are continuously chatting over here in live chat, the link is going to up over there. So kindly browse and check for the link. So in the chat column, we have given the link. So since all the participants are continuously messaging in the live chat, the link is going up. You are pasting it again and again. I will paste again. So kindly check for it. Kindly check for the chat link. Or the participants are advised to scan the QR code also. So the participants can either scan the QR code for the feedback link. The participants can either find the code in the live screen or in the chat column. So the participants, you have two options. Either you can scan or make a screenshot of the QR code and scan from that and give the feedback, or else you can find the direct link in the chat column. The link has been added to the description of the video as well, so you can even found over there. The link for the feedback has been added to the description column as well. We can find over there. The participants are requested to check the description column of the live session. There also we have pasted the feedback link, or you can find in the chat column, or you can even scan the QR code which is displayed right now in front of your live screen. The responses has been activated, so you can fill right now. Yeah. So the participants who have got the link can close the session and kindly fill the feedback form. We have resumed the responses. You can fill right now. It is accepting the responses, and the participants who have got the form link can close the session, and we will meet tomorrow. And the feedback links, I will even mail to your concerned email IDs. You can even write your feedback and you can send it us back. So the participants who are not still finding difficult to get this feedback form, I will mail you the feedback form link to all of your mail IDs and you can respond to that. So the participants can close the live session. For those who find difficult in getting the feedback link, either you can find it in description or you can find it in the live screen QR code, or after this meeting we will mail you. Okay, so the participants who doesn't got the feedback form yet, we will mail you the link also. If you find difficulty in finding it in description or in QR code, so the participants can close the session as of now and we can meet tomorrow.